This is the video for Mod 4 Lesson 2, Solving Systems of Equations by Substitution. The goal of today's video is going to be learning our second method for solving a system of equations, which is solving by substitution. The steps listed that we're going to use are listed in your notes, and we're going to use these steps when we go ahead and solve. So the first step is we're going to end up isolating or solving for one of the variables, and typically we're going to look at where there's a coefficient of 1 or -1. We're then going to substitute the expression from step 1 into the other equation, and then simplify, solve, and then resubstitute to get the second variable, right? So we're going to go through a few different examples, what to do when it's in a form where it's already as x equals y equals, and what to do if it's in standard form, which we'll talk a little bit about. In this example, we're going to look at solving with substitution. In the previous section, we looked at solving with graphing, where we found where the two lines intersected, and that was our solution to the system. So that was a value of x and y. That was true for both equations. For this method, it's a little more algebraic. So we're going to be looking at using, some of the solving properties we used from last semester to get our values from x and y. And this usually is a little better to use when we're working with a solution that might be a decimal or a fraction. So the first thing is I'm going to go ahead and actually number these equations just so when we're talking about them, they're a little easier to look at. And so I see one equation is y equals 3x plus 2, and the second equation is x plus 2y equals 11. So the first thing is we want to identify which of these equations has a variable that is isolated. So a variable that's on a side all by itself, if we have one. And we actually see that in equation 1, y is already by itself, and I already know y is equal to 3x plus 2. So what we're going to do, I'm going to go ahead and just rewrite it below. So I have one equation that's y equals 3x plus 2, and that's the one with the variable by itself. And I have my second equation, x plus 2y equals 11. So what we're going to do now is we're going to take this expression of 3x plus 2, and then we're going to substitute it into the second equation. So wherever I see a y, I'm going to box it as well. I'm basically going to rewrite it, and in its place, just kind of leave a parenthesis here. And in place of that y, I'm going to substitute the expression 3x plus 2. Okay, so basically what we did is in place of the y, we replaced or substituted 3x plus 2. And we know that we did it correctly because if I look at my equation, notice that the only variable I see now is x. So I don't see x and y now both in there. Same thing if I was to do it with the other variable. I don't see different types of variables in there. I only see one variable, in this case x, but I see it a couple times listed there. And so now, once we substitute that in, we're going to go ahead and use all of our solving properties that we learned last semester for solving equations. So I'm going to look at my left-hand side. I see a parenthesis, so I have to distribute and simplify this side. So we actually get this to be 6x plus 4 equals 11. I'm going to go ahead and combine like terms. And then now it just becomes a two-step equation. So I'm going to subtract the 4 and then divide by 7. Okay. So my first piece I get is x is equal to 1. And that was actually, a lot of work, but we're not really quite done with the problem yet. We still have to go ahead and simplify and evaluate to find our other variables. So really we just found half the problem. The second half of the problem though isn't as complicated. So now that I know x is equal to 1, I'm basically going to substitute this 1 back in. I could do to either equation, but I'll probably do back to the one where it's y equals because it's a much easier problem to use. If I use the other one, I'll have to do a little more solving. So I'm going to go ahead and substitute that 1 in. So I have y equals, I'm going to put a 1 in for x now. So I have 3 plus 2, and my answer is 5. So my final answer for this would be 1 comma 5. In the part B, it's the same type of problem. So when we go ahead and look at this, I'm going to name it equation 1 and 2. And the goal is I'm going to look for which of these equations has a variable that's already isolated or by itself. In this example, I don't have any equation that has a variable on a side already by itself. So then that's when we would look to see if we see any of them that maybe just have a coefficient of 1. So we only see 1 or negative 1. In this case, in equation 1, I see the x is kind of, has that coefficient or value in front that's a 1. So we're going to go ahead and rewrite this now and solve for get x by itself. So we're going to rewrite it now so that variable is by itself. Okay, so now we end up having something that we're kind of just saw in the last problem. So I have one equation that is 4x plus 6y equals 4. And that was my equation 2. And then I have another one that's x equals 2y minus 6. Okay, so now we're going to do the same exact thing we did before. I'm going to go ahead, I see an x is by itself. The expression that it equals is 2y minus 6. So I'm going to go to the other equation. I see an x with that 4x, and I'm going to replace that x with the expression. So you can rewrite it with the parenthesis first, and then in place of that x, I'm going to write now 2y minus 6. Okay, the way that we knew that we did that correctly is when we substituted in. Notice I only see y's now. I don't see x's and y's in the same problem. And then from here, it's just going ahead and simplifying and solving. So we have 8y minus 24 plus 6y equals 4. Going to combine like terms. And then just simply solve for y. So nothing really too new after you substitute in. So we get our y to be 2. And again, we're not done with the problem once we get one of the variables. We then have to substitute it back in. So I'm going to go ahead and in that other equation now, wherever I see a y, I'm going to put a 2. Again, you can use either equation, just that one where x is by itself is a little easier to use. So 4 minus 6, we get negative 2. And so my answer for this would be negative 2 comma 2. For part C, again, same type of problem. We're going to go ahead and I'm going to just call it equation 1 and 2. And so I see for the this, again, I'm going to pick an equation where the variable is already isolated or by itself. And I see I have y already by itself in that first equation. So if I go ahead and now I'm going to rewrite this down here. So I see a y with the negative 3x plus 8. In the other equation, wherever I see a y, I'm going to substitute negative 3x plus 8. Okay, again, we know we did it correctly because when we substituted in, notice I don't see x's and y's in the same problem. I only now see x's. And now we're going to go ahead and simplify and solve. So notice we're distributing a negative 5. So you want to be careful you're watching your negative signs. We're then going to combine like terms. We have a negative 40, so remember we're adding, and then we're being careful when we add and subtract our negative numbers here. And then our final answer would be 3 for x. And then when we get our first variable, again, we have to substitute it back in. So I see that first equation, negative 3x plus 8. I'm going to put negative 3x plus 8. I'm going to put that 3 in. And we get negative 1. So our final answer would be 3, negative 1. In the second example problems, again, it's kind of just business as usual. We're going to go ahead and solve. The only thing that comes up with these is when we get our start to work out the algebra, we'll notice something interesting happens with our answers or our work, and we want to know what that actually means, right? So for this one, if we approach it the same way as the last 2 problems or 3 problems, I can see I have y by itself on that first equation, and we can go ahead and just do our substitution. In place of y, I'm gonna substitute 8x minus 7. Then when we go ahead and simplify, we're going to go ahead and distribute. And we actually notice that something happens here. We have our 16x's actually, when we combine like terms, this becomes a 0x, or we can just cancel that out. And then we end up with a statement here that says negative 14 equals negative 18. That's actually not a true statement, right? Those, I would say they're actually not equal, that's a false statement. And so what that means for this system is there's actually no solution. If I saw this on a coordinate plane, this would mean that the lines were parallel to each other. This would be an example of a no solution. And then finally, for the last one, same thing. I can go ahead and isolate here. I see my x is by itself. And so wherever I see an x, I'm going to substitute in into my second equation. And you can see when I actually look at this, there's actually a little negative that's in front. So that's like a negative 1 that's there. So I have negative 1. I'm going to substitute in that expression. When we distribute, we get 3y minus 12 minus 3y equals negative 12. When we combine like terms, the 3y's actually cancel out, and so we end up with a statement of negative 12 equals negative 12, which is actually a true solution, right? We don't have any variables left. So this one we would say there's infinitely many solutions. All right, and then you would be done with the problem. If you have questions, make sure you are trying the U-Try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.